I made this video to show you how to calculate percent error for part 4 of your measurement lab. In part 3, you calculated density for 3 different tools: the most precise tool, the runner-up most precise, and the least precise tool. And then after you had those densities 3 separate times, you did an average for each tool and a standard deviation for each tool. For mine, because the densities all rounded to the exact same number, my average came out to be the same and I had 0 deviation. So my average density for my made-up data is 1.2 grams per milliliter. What we do in part 4 is we find out how accurate is that. We do that by calculating percent error. It tells you in the lab handout that you can find the formula for percent error in your textbook. Here's a screenshot of that. It also tells you that we can find the actual value of the density of water in your textbook. So here's a screenshot of that. So what we're going to do is, with my fake data that I made up, use this formula. So first what we have to do is get error, and then the error gets plugged into percent error, and those bars mean absolute value. So if I get a negative number up here, I will not plug it in as a negative number in percent error. It's always a positive number. So I need the experimental value that I got, and I need to subtract the accepted value from this table down here. So on the table, the accepted value of density of water is 0.997. So to get the error, I need to take the 1.2 grams per milliliter that I calculated and subtract from it the 0.997 grams per, they say centimeter cubed. That is the same thing as milliliters. So I need to subtract that. Pull up a calculator because I'm not doing that in my head. And I need 1.2 minus 0.997. So the significant figures rules for this operation deal with location of significant figures. I have my farthest left significant figure is in the 10th place, which means I need to round this to the 10th place. So I'm going to write down that my error was just 0.2. I'm going to come over here and write down with the correct side of the pen that my error is 0.2 grams per milliliter. So now that I have error, I'm going to plug it into the percent error equation. So to get percent error, I need to take that error, the 0.2 grams per milliliter, and I'm going to divide it by the accepted value. So I'm going to come back to this table again and take the 0.997 grams per milliliter. So I've got my error on top, the accepted value on the bottom. Whatever I get here, I need to multiply it by 100 because that's what's going to make it a percent. So let's calculator again. So my error, I'm not going to do the 0.203 because I had to round to sig figs. I'm going to put 0.2 divided by 0.997. And then I get this thing, I'm going to multiply it by 100. So I get 20, I think I told you in the lab to round to the 10th place on this percent, so we're going to call that 20.1% error. So we would write that the percent error is 20.1%. So this alone doesn't look all that accurate. We were off by 20%, but really what you'll need to do is calculate it for the 3 different tools, and whichever one has the lowest percent error would have been your most accurate tool.